Science in Pajamas. Alright, so we are continuing on talking about acceleration, and we have a few problems that we are going to look at. So here's the first one. The car speeds up from 25 meters per second to 30 meters per second, and it took it 3 seconds to do this. What is the acceleration? Now first let's review the acceleration equation. So if you remember, it is the acceleration equals final velocity minus initial velocity over the time. So now we have our question. We got to figure out what's going on here. So the car speeds up from 25 meters per second. First of all, we know this is a velocity because of the unit. The unit, meters per second, tells us it is a velocity. To 30 meters per second, we know this is also a velocity because of the unit. Now the wording of it, it goes from this to this. That tells us the order. So it's starting out at 25 meters per second. That makes it our initial velocity. And it ended up at 30 meters per second. So that is our final velocity. And how long did it take? It took 3 seconds. How do I know that this is the time? By the unit, seconds. So it took 3 seconds. So what we are looking for is the acceleration. And it even says that right there. What's the acceleration? All right, so what we are going to do is we are going to go ahead and plug this into our equation. So we know acceleration equals the final 30 meters per second minus our initial 25 meters per second. And we divide that by our time, which is 3 seconds. So 30 divided by 25 would be 5 meters per second, and then divided by 3 seconds, our acceleration equals 1.67 meters per second squared. All right, see, not too bad, right? Could be a whole lot worse. Could be a heck of a lot worse. So let's go through and do another one together, all right? I'm going to do a few of these. Here's our next problem. So we have the car slows down from 45 meters per second to 37 meters per second. And this occurs in 4 seconds. What is the acceleration? So it tells me what I'm looking for. I don't know the acceleration, that's what I'm solving for. I know the time in seconds is 4 seconds. And meters per second, those are my velocities. Now which one is which? Which one's final? Which one's initial? Well, it says it slows down from this, so that's my first one. That's my initial. To this one, so that's my final velocity. All right, time to plug and chug, as they say in math classes. So we're going to plug this in. We know acceleration equals final minus initial. So the final minus the initial is 37 meters per second minus 45 meters per second. And we're going to divide that by the time, which is 4 seconds. All right, let's get to it. 37 minus 45 would be -8 meters per second divided by 4 seconds equals -2 meters per second squared. The negative sign simply means that the acceleration is happening in the opposite direction of the velocity, which it makes sense because remember, it's slowing down. So its velocity is decreasing. Not horrible. Hopefully not horrible. Let's do a few more of these. We're going to switch it up a little bit. We are going to switch them up a little bit. You guys ready for the next challenge? Alright. So the car accelerates at a rate of 3.3 meters per second squared. Its final velocity is 53 meters per second. This occurred in 4 seconds. What is the initial velocity? Uh-oh. Changing things up on us. We don't know the initial velocity. That's what we're looking for. It tells us the rate of acceleration is 3.3 meters per second squared. Even if you weren't sure about that, take a look at the units. Meters per second squared. You can tell that with it being meters per second squared, it's not velocity. The final velocity is 53 meters per second. And it occurred in 4 seconds, so there's my time. Now we can't just straight up plug this in. We need to rearrange the equation first. So I'm going to put this up and to the side, so we don't forget about it. Alright, so we have acceleration equals final minus the initial over time. But this time I want to solve for VI. So that means that I have to rearrange it. That means I'm going to want to get the time out from the bottom. I don't want to in a fraction anymore. I'm going to multiply both sides by delta t. I forgot to put the delta in earlier. I apologize. So now we have acceleration times time equals VF minus VI. All right. What I'm going to do is add VI to both sides. Yes, I know I'm solving for it, but I don't really like the fact that it's minus because that would make it negative. That'll give us VI plus acceleration times time equals VF. All right, now we just gotta get VI by itself. So I'm gonna subtract the acceleration times time, cancel it out on that side, and subtract it from that side. So we are left with the initial velocity equals final velocity minus acceleration times time. You see? There we go. Now that we have that all done, we can easily just plug it in. This we can work with. So we have VI equals VF minus A delta t. So the final velocity is 53 meters per second minus the acceleration, which is 3.3 meters per second squared, times the time, which is 4 seconds. All right. Well, if we were to go through, we multiply this, we subtract it from that, we end up getting that the initial velocity had to have been 39.8 meters per second. All right. See, might have been a challenge, but it's one we can handle because we are smart. We are SMRT, as Homer Simpson says. Let's do another one. Wahaha. All right. This time, though, let's look for the final velocity. Dun, dun, dun. Right, so first, let's go through our problem. Car is traveling at 24 meters per second. It accelerates at a rate of 3.7 meters per second squared for 5 seconds. What is the final velocity? All right. So final velocity is our unknown. The car is traveling at this velocity already, so that means it has to be our initial. It accelerates at a rate of 3.7 meters per second squared. There is our acceleration. There she blows. And how long does it accelerate for? 5 seconds. All right, I'm going to put this up here. I'm going to look at the equation now. So A equals final minus initial velocities over our time. I want to get final velocity by itself. And the first thing I'm going to do, get rid of my time at the bottom of the fraction, and multiply both sides by it. I'm left with acceleration times time equals VF minus VI. Alright, again I want VF by itself, so I'm going to add both sides, add VI to both sides. We are left with VI, so the initial velocity, plus acceleration times time equals VF. So you got this. Alright, so now let's solve it. VF equals VI plus A times delta T. My initial velocity is 24 meters per second plus the acceleration, which is 3.7 meters per second squared, times the time, which is 5 seconds. And we get that was a little bit harder on my arm than I was expecting it to be. When we do that, we get 42.5 meters per second. And that is how we solve for our final velocity. See, you guys got this. You're smart cookies. Alrighty. I'm going to do one more and then we'll call it a day for this equation. Or at least for this video. Don't worry, got plenty more practice to do with other videos. So car at rest speeds up to 40 meters per second with a constant acceleration of 2.1 meters per second squared. How long does this take? All right, so what do we know? We want to know how long it takes. So that's going to be our time. That's what we're solving for. The car is at rest. When it's at rest, that means it's not moving. If it's not moving, that means it has a 0 initial velocity. And it speeds up to 40 meters per second. The acceleration is 2.1 meters per second squared. All right, we are ready to rearrange our equation and solve for it. Woohoo! All right, so we have our equation. A equals VF minus VI over delta T. Now this time I want to get time by itself. That means I definitely do not want it underneath the fraction. We multiply both sides by T. Get it by itself. And cancel it out on that side. And you're left with A times delta T equals VF minus VI. All right, well now, we gotta get t by itself. So I'm gonna divide both sides by a. Now cancel it out on that side, and we are left with delta t equals vf minus vi over acceleration. We are now ready to go ahead and plug this in. So we have delta t equals vf minus vi over a. The final velocity was 40, minus the initial, which was 0, over 2.1 meters per second squared. We go through, these 40 minus 0 is just 40, divide by 2.1. The time it took for it to accelerate to 40 meters per second is 19 seconds. See? Not too bad? All right. So I hope this helped you guys out. And until next time, we'll see you later. Take care, you guys. Be safe, be awesome, be amazing, and catch you later. Yep.